I would like to show some results that we have done on the GPU performance benchmarks. Yeah, this is the system that we use for the CPU benchmark and also the fast swap systems. So first of all, that we use Wiwynn multi-purpose server. It's called SV300. Right now it is generation 3, this Skylake platform. So that's CPU platform. So the CPU, we choose the 6130. Also have we installed with 16 pieces of DIMM sockets. Actually, the chassis design is 24 DIMMs. We choose some boot drive from the partner Intel. But this is only a CPU computing server only. Yeah, and we have the other product, we call it our extended computing or extreme computing 200. Actually, this is one is just pure PCIe box that we use Broadcom's PCI switch, Gen 3 switch. Yes. And we have first installed 8 pieces of V100 GPU card and connected to the CPU socket 0 using the external mini-SAS HD cable. Actually, the HD cable is running by the PCI interface. And we also put another 8 pieces of V100 GPU card and connect to another CPU slot. So this is the phase swap user system, and also later you will see the performance benchmark by using these system configurations. Yeah, in this benchmark diagram that you may show in the yellow line, it indicates the ideal speed up. That means use one piece of GPU versus 2 pieces of GPU. So that means theoretically the throughput will be double. But actually know that sometimes in the system testing there will be some overhead. So actually, after we done the performance benchmark testing, then we find that when the GPU amount goes doubles, the training throughput is going to about 1.7 to 1.8 times when the GPU amount goes doubles. Okay. But however, you will find that when we grow up the GPU from 8 to 16 pieces, you find that performance is degraded. Okay. In this test case, we use a TensorFlow pattern of the AlexNet. AlexNet, as you know, that it is a very big deep learning models. So the performance is impacted because for the big deep learning models that we needs a very massive data transmission bandwidth. So as you see the system configuration that we shown on the last page, that you may find that we installed 8 pieces of GPU card to the CPU 0, another 8 pieces to the CPU 1. So during CPU 0 and 1, there were UPI interfaces between the between the CPUs. So for the big model, big deep learning model, example, the AlexNet, so the bandwidth is impacted by the UPI links. So you may find when GPU cards grow from 8 to 16, the performance is very largely degraded. In contrast, when you choose another deep learning model, for example, this is another TensorFlow inception version 3. Okay, so the gradient seems good, even from 8 to 16 pieces. So that tells us that because inception just not need that dense transmission bandwidth, so the UPI performance impact is not so high. So when you choose a small model of the TensorFlow or any other of the AI applications, then you can still use a CPU with the UPI connection to the GPU cards. Okay, so until now, that I just want to describe that. Besides that, we will provide some powerful hardware products. Yeah, you may see that we also have a very strong software team that they can help us or help you to give you some advice about how to choose Wiwynn hardware platforms, and also advise you how to provision or build up your best system architecture according to our experiences. So I would like to tell you that our team is ready for you, that if you can take some POC chances, they can give you very good advice. Yeah, and after that, so I have to say some words that regarding Wiwynn's products, so that I will start to introduce GPU product that Wiwynn already have or is going to have. Yeah, so there are three categories about these product lines. So first of all, you can choose according to your needs. So if you just has existing or your current rack platform, for example, for the 90-inch, so you may choose from the 90-inch products. The mapping products that is SV500s. Okay, it is for you. Can be installed with 8 pieces of GPU cards. So if you will build up a new rack architecture to your data centers or to your site, that you can choose in the OCP 21-inch racks. We have another product, SV7400. Actually, it is a similar design as a SV500. The difference is between this one is 90-inch, this one is 21-inch. So if you have already existing servers, but you need extra GPU, so we have another product line. It is compute accelerators. It's a XC200 series. So basically, it just provide a PCIe interfaces box. So you may install 16 pieces of GPU cards inside these chassis. So remember that we use this system to do the phase swap use cases. Yeah, with those product lines, so we can simply divide our product line into three categories regarding to the workload. So we have workload for the 1 to 4. That means the 1 server node share the 4 GPU cards. The other workload that we provide is 1 to 8. The third one is 1 to 16. Of course, the configuration will depend on your real workload. You can choose 4, 8, or 16 per your demand or per your applications. As mentioned, that our experienced team can also give you advice how to configure our systems to fit your need. Okay, here's the first product, 21 inches. Okay, right now we take the PCI Gen 3 switches. Okay, each one has 16 PCI lanes. So you may find that will be installed with 8 GPU cards inside there. Okay, so that means for 8 GPU cards, it's very suitable for your large simulation model and can be efficiently to shorten your training tasks. The third point to stress this one is this device just integrated with field-proven motherboards. This one is from OCP's subgroup, Project Olympus. Okay, as you may know that Project Olympus server board is adopted by the Microsoft. So use the field-proven motherboard to integrate the systems to make it more mature for your requirements. Okay, so how to map to the workload requirement between our last pages. So it is can input with 8 pieces of GPU cards. So this is suitable for your 1 to 8 GPU workloads. The next product is 90-inch product. Okay, it's SV500. Okay, basically the design is similar approach to the 21 inches. It uses also for the workload 1 to 8, and with a motherboard from the Olympus project. Okay, and the difference is that because the chassis in the 90 inches shallower than the 21 inch, so you may find that in this model there's only 4 2.5 inch drive supported, but in the last products you have more drives, up to 8 pieces. Okay, sorry. The third product is GPU box. You can also call it the J box. Okay, so it supports 16 PCI slots. And actually, beside the GPU card, you can also install any kind of PCIe adding cards. For example, we just co-working with Intel that we are now developing and validating their pack card. That means they are FPGA cards. So it's easier to your demand by using the GPU or even the FPGA card by using this chassis. Okay, and in the design, when you install 16 pieces of adding card, no matter if it's FPGA or GPU cards, that it will become more heavier. So we have the 4-drawer design to make it easy for your maintenance. And also, when you maintenance adding card inside a single chassis, if you attach it another drawer to another service, then the service from the other drawer to the service will be not interrupted. So this design flexibility from our systems.